Yeah, good afternoon, dear ladies and gentlemen. Welcome to our presentation of Secardeo certACME version 2. We released a new version of certACME, and I will introduce you into the new functions and innovations in this new software release. So in the next 30 minutes, you will hear the following. I will give you an introduction to the ACME protocol. Then I will explain what are the benefits and the basic functionality of certACME. Then a new feature, we have an ACME backend now for connecting to CAs like Let's Encrypt and so on. I will explain that. And then we have a couple of advanced security features that I want to explain. I will introduce you into the crypto policy, ACME Whitelist, ACME request acceptance, external account binding. So these are very interesting security options that I want to explain. And then also a very new feature is the use of the ACME protocol for device certificates using Apple's device attestation. Yeah, and then I will give you an overview of further innovations in the new release of certACME, and I will close then with a summary of everything. So first, let's start with the TLS certificates. TLS certificates are primarily used for authentication of web servers and for the negotiation of session keys in the TLS handshake. So typically you are aware of server certificates, but there are also client certificates in use that are used for mutual TLS authentication. Yeah, the CA browser forum, they have published guidelines, especially the baseline requirements that define the handling and organizational requirements for publicly trusted TLS certificates. Yeah, and the CAP forum 2 weeks ago, they decided about new validity periods of certificates. Today, the validity can be up to 398 days, so it's more than 1 year. But they will go down now step by step. So in the next year, we will get half of it, around 200 days. The year after that, 2027, we will have 100 days, and in March 2029, the goal is to go down to 47 days. This was pushed by Google, and Google promoted 90 days, and then Apple promoted 47 days, and so this is the decision and the planning of the CAP forum. Yeah, and this means if we have such low periods, validity periods, then we really need an automation of all these issuance processes. So, and ACME is exactly the automation protocol that you will need here. It's a standardized protocol, automated certificate management environment, and it was designed to provide web servers with SSL TLS certificates. The ACME RFC covers only domain validation, not OV, not EV. These are additional requirements. And the RFC, the protocol, was originally developed for Let's Encrypt. So Let's Encrypt is a public free CA that you can use by using the ACME protocol. Yeah, and the idea of ACME is that the CA validates the identity of a web server by using a challenge. So now today I talked about web servers primarily because this was the initial idea of ACME. So in the Let's Encrypt scenario, we have an external server who will contact Let's Encrypt, the public CA, and request a certificate. But we have also use cases for internal servers that will use either an internal private CA, or they could also request certificates from a public CA. Yeah, we have also customers that use the ACME protocol for client certificates from their internal CA. Yeah, and the new challenge now is that Apple also supports device certificates that, of course, will then come from an internal private CA. Yeah, there are still some open points of challenges when using ACME. If your company uses ACME for your external, internal servers, whatever, so as we have server 1, server 2, server 3, all they will get certificates. But this is only under control of the administrator of the server. Yeah, and then we have a fourth server who wants to get a certificate from the Microsoft CA, ADCS, but this doesn't work because Microsoft doesn't support the protocol. Yeah, and the main challenge is if we have not 3 or 4 or 5 servers, but we have 300, 500 or 3,000 servers, and we have customers that have this number of servers, you will lose control. So the goal is really to get a centralized control over everything, and this is what certACME will serve. certACME is basically an ACME proxy that talks the ACME protocol with the ACME client. The ACME client is located on a web server or on a Kubernetes cluster or on a load balancer or whatever. So here we talk the ACME version 2 protocol with these systems. And on the other hand, we have interfaces with certain CAs. This is only a snapshot of the supported CAs. And all these CAs have different protocols. That's Encrypt has ACME, SwissSign has CMC interface, ADCS has the WCC interface, EJBCA has CMP, and so on and so on. And so we have connectors for all these CAs. And at the end, the certificates will be stored in a central database where they can easily be managed by central IT. Yeah, then if we look at the validation scenarios that certACME performs with the ACME client, in the first step, the client will register and will place an order in order to get a certificate. And the certACME will then return the validation options that are possible. And at the end, the ACME client will say, okay, the challenge is complete. And certACME will then verify if the challenges have been fulfilled. So the standard or the most often used validation type is HTTP. So the server will put the challenge on a URL on the web server, can be reached over port 80. Another option is DNS validation. In this scenario, the ACME client will publish the challenge in the DNS, and so ACME will verify that. And what is new? These were validations options in certACME version 1 already, and now in version 2 we have an additional validation option for TLS ALPN. TLS LPN works on port 443, so this means you don't have to open port 80. And this is often a security issue It's forbidden to open port 80 by policies. And so we can use port 443. And the challenge is then signed with the private key of the ACME client, and the certACME will then validate the signed challenge in order to go on with the request. Yeah, we have, as I mentioned already, we talked with ACME clients and we talk with backend CAs. These clients, these are standard clients that we already supported in version 1. And now in certACME version 2, we have a couple of more clients. The built-in Apache client, for example, a Kubernetes client, and so on. On the CA side, we supported the Amazon private CA, SwissSign, and the Microsoft CA. And now we extended this for a couple of public CAs, DigiCert, GlobalSign, dtrust, and also private CAs, public open source CAs like DocTech and OpenX PKI and EGP CA. Yeah, and what's really new is the support of an ACME backend, where you can encrypt to public CAs like Let's Encrypt or ZeroSSL or whatever. So yeah, let's look at this scenario with the ACME backend CA. So in this scenario, we have certACME as a proxy. We have an internal server, server 1, and we have an external server, server 2. So we start with the external server. So the external server will perform the ACME protocol with certACME. So at the end, certACME will then start another ACME protocol with the ACME backend CA. It will place register order, and then will perform a DNS validation. So the challenge will be published in the DNS. For this, certACME needs write permissions on the DNS. If we look at the internal server, it will also talk the ACME protocol internally with certACME, and it can be handled the same way. We register an order for this, and we can also perform a DNS validation for the internal server. By the way, this works only if the internal DNS is under the public DNS. In this scenario, we have secardeo.com as a public DNS entry, and we have intern.secardeo.com for the internal network. This works. What will not work are domains like secardeo.local. This will not be possible. But this is a typical scenario that will work. Yeah, the other option that we could use is HTTP validation for the internal server. So we can publish the challenge from the CA on port 80. And we have another option. If certACME resides completely internally, it's not reached from the outside, then we can use a validation server. This is basically a web server that resides in the public internet. And so ACME will just copy the challenge to the validation server, and the validation server can publish it so that the ACME CA can validate the HTTP challenge. Yeah, this was the ACME backend CA. Now we come to the security features of certACME. What you see here are two security features that we already had in version 1. It's a whitelisting and it's the ACME request acceptance. I will slightly explain that afterwards. But we have added two new features. One is the crypto policy, and one is the authorization with external account binding. I will explain all these features in the following. A crypto policy can be defined via the Active Directory template. So you can configure all these options in the AD template, or you can do it in a local configuration. Basically, what we look at here is the algorithm, the used algorithm, the key size, the key size for renewal of the certificates, and we can also check if the certificate renewal is done with a new key pair. So all this can be defined and will be validated by certACME. Yeah, then the whitelist. The default behavior of certACME is that all domain names are allowed. Yeah, there's no check, but you can use whitelist in order to restrict the used domain names. And you can define a whitelist per certificate template. It's basically a text file that contains DNS names. In the table below, you have some examples. So we have explicit DNS names, or we can also operate with wildcards, star.example.com, for example. So this is rather flexible in order to get a control over the used DNS names. In version 2, we have extended this whitelisting for Apple device IDs. So if you perform device certificate enrollment, you can restrict this to certain device IDs. I will come back to this later on. Another interesting feature that we had already in version 1 is ACME request acceptance. In this scenario, we have an ACME client and an administrator. So the administrator will start the ACME process, and at the end, it will send a request to certACME. And certACME can, on the one hand, it can make a policy validation. It can check in the whitelist. And if the request acceptance is enabled for this specific template, then certACME will put an entry into the approval queue of certLive. And then we have a person with the role approver that will get this request, and the approver can then inspect the request and say, okay, this is okay, this server or this ACME client can get the certificate. So then he will accept the request using the certLive web interface, and then certLive will send a notification to the admin, and the admin can perform a re-request. So he will repeat the request, basically, and then this request will pass through, and certACME will send the enhanced request to the CA, and the CA will issue the certificate, and certACME will return the certificate to the ACME client on the server. So the request acceptance is only done for the initial request. All further renewal requests don't need this security feature. Okay, so what's new in version 2 is the support for external account binding. External account binding is a feature that is standardized in the ACME RFC, and it works the following. So we have the certACME configurator on the server. This is a client application that can be started on the server where certACME is installed. And with the configurator, you can create an EAB token. An EAB token is basically a key, a MAC key, with a key identifier, KID. And we will create the EAB token for an administrator, and the administrator is a member, it's a user in the Active Directory. So we can select the user and say, okay, this user will get this EAB token. Then the admin will install the EAB token on the ACME client. And in the next step, when the client wants to create a new account, before it will submit the CSR, certACME will validate the EAB token that will be passed from the client. It will validate it cryptographically, and then the order comes for a certain certificate template, and then certACME will do a permission check. So for this template, this is an Active Directory template. The Active Directory template has certain permissions, and we will check the permissions if the administrator, that's the owner of this EAB token, has enroll permission for this template. And only if the admin has enroll permission, certACME will allow the request and will pass the enhanced request to the backend CA. The backend CA then issues the certificate, certACME returns the certificate to the client, and everything is okay. So we have a very high level of security and control options using EAB tokens in combination with Active Directory enrollment permissions. Yeah, a completely different scenario is the Apple device attestation. Apple offers support for ACME payloads since iOS 16, and device attestation is done for devices by Apple. This can be combined with hardware security. They call it Secure Enclave. The Secure Enclave will generate a key pair, and the private key is never exportable from the hardware, so it always resides in the hardware. It's a little bit like a smart card, but it's inside of the Apple iPhone, for example. Yeah, and for this device attestation, today we don't have an RFC. There exists an IETF draft, and Apple implemented this IETF draft. And what we did, we also implemented this IETF draft in order to support Apple device attestation. So how does it work? So on the left, we have a managed device, an iPhone, for example. We have certACME, we have an MDM server. On the top, we have an Apple attestation CA. And below, we have the enterprise that we will use to issue device certificates. So what happens? The MDM server is configured for device attestation, and it will send an ACME payload to the managed device. Then the managed device will create an account and order, and certACME will return and say, okay, validation type is attestation. Please perform attestation. Then the device will contact the Apple attestation CA, and it will request an attestation. And then the attestation CA will issue an attestation, which is basically an X509 certificate. So the certificate contains device-specific information, especially it contains the serial number, UDID, and other attributes. So then in the next step, the Apple device will send, it will generate a key pair. It will then submit the CSR with the attestation certificate to certACME. certACME will validate the attestation certificate, and it will validate, of course, the CSR. And then it will check if the provided serial number is a corporate serial number. Yeah, because Apple issue certificates for all Apple devices, but here we check if this Apple device is really a device that belongs to the organization. We can do this either by contacting the MDM server. Here we support Intune and Mobile Iron. So we can ask the MDM, hey, is this device a managed device? Or we can perform a check on a whitelist, where the whitelist will contain all the serial numbers. Yeah, at the end, if everything is okay, we will pass the certificate request to the enterprise CA. The enterprise CA will issue the certificate, and we will return the certificate to the managed Apple device. Yeah, so these were the very let's say complex innovations, but we have a couple of other innovations in version 2. We have a client edition now for client authentication certificates. So if we have customers that don't use it for servers, so we have a client edition. We have improved performance significantly. This will be very important if you have many requests per time, then you will have a very better performance than before. So we ported it to .NET 8. We support Windows Server 25. We have new ODBC drivers. We can enroll or auto-enroll the own certificate for certACME. So this is also automated inside of certACME. We can perform log rotation, so you don't have only one big file that grows and grows and grows, so we can put it into smaller chunks. We have software update info like in certLive, so the admin will be informed when there's an update available, and then he can do a very easy software update. Yeah. And at the end, I will show you how certACME integrates within the Secardeo TopKey platform. The TopKey platform consists of several components for enrollment, key distribution, key retrieval, key certificate publishing, certificate auto-revocation, and what's very important is the central role of certLive for the overall certificate management. So all these components use a central database, the certificate database, and certACME will put all the certificates into the certificate database so that they can be easily managed by certLive, for example. Okay, so I just want to summarize it up. So certACME is a proxy for central auto-enrollment of SSL TLS certificates. We have tight integration with ADCS, and we are using AD templates. And what's new is we have support for further ACME clients and CAs. We have also the option to enroll from ACME CAs like Let's Encrypt. We support TLS ELPM validation without having to open port 80. We support external account binding in combination with enrollment permissions in Active Directory templates. We support ACME device certificate enrollment using Apple device attestation, and we have implemented many other functions and improvements in the product. Yeah, so I'm now at the end of this presentation. Thank you very much